Okay, Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi ta'ala wabarakatuh. Alright, so we are going to continue to new topics, which is introduction to systems. Okay, so previously we have learned about introduction to signals, how to classify, how to represent a signal, and how to do operation on a signal. Okay, so in this new topics, we learn about concept of system and how do we classify a system. Okay, so before we go to the an example and classification of system, I would like to share this beautiful system that is created by the Almighty Allah Subhanahu Wa Taala that we are having every day. Okay, so every day we see the sun. Okay, we feel the warmness of the sun. Okay, and then at night we are not in the dark. Allah gives us moon, okay, to generate light. Okay, so in the surah number 25 ayat 61, Allah explained that blessed is he who made constellation in the skies and placed therein lamp and moon giving light. Okay, so Allah create the earth, okay, for us to live, and He also provide us an oxygen, the sunlight, okay, everything with a beautiful system around our atmosphere. Okay, so to make us feel comfortable, okay, and reflects as well the existence of Allah Subhanahu Wa Taala. Okay, is a signal. Okay, signal that Allah is exist. Signal that there is someone who created us, created the system. Okay, so some reminder as well. If you come across, there is a sharing that if we listen to the Quran, okay, so it will increase immune system and makes our brain active, and also avoid forgetful in our in the like when we old. Okay, so it can prevent that we always forget something like that. Okay, so it can be activation to our cells to cure illnesses. Okay, and it is also in the ayat 204 from surah number 7. So when the Quran is recited, then listen to it. Okay, Allah instruct us to listen and pay attention that you may receive mercy. So what is the mercy? It can come from the good health. Okay, so this is also a kind of signal. The nature we have learned before, right? The signals can come from the nature, like the reading of Quran. Okay, so it is a deterministic signal. Okay, where we can see the reference, okay, the which ayat or the signal that comes from the beautiful recitation of Quran, right? Okay, so we go to the definitions of system. Okay, it is a mathematical transformation of an input. Okay, so basically if we have input, it comes to a system. Okay, so it will goes to the output as different signal. Okay, later on we will also learn that if it can get to the input signal the same amplitude, the same time domain, the same like the input, so it is called reversible. Okay, so previously we have defined signal is a set of data or information, so it will goes here, this information, It can be also a function. Okay, function means an equation. So if it's a function, so it will be a periodic function. Okay, so it is also represent information, or it can be a function of one or more variables that conveys information on the nature of physical phenomenon, okay, such as our voice, such as the Quranic recitation just now. Okay, so it can have more than one parameter. Okay, and a system is an entity, okay, that process. Okay, so we do some process here. Either we subtract, we multiply. Okay, so we multiply with another signal such as modulation, okay, to a set of signals as an input to yield another set of signal that we call output. Okay. Alright, so it is also designated as xt, the input, and the output is yt, or we can call it as excitation, the input, and the response, okay, or the outcome is the output of the system. Okay, this is a basic communication system. Okay, when in the chapter 1, I give you an example where we speak, okay, and then it come across to the transducer, amplifier, and then it goes to the listener or the receiver. As the listener, it can listen back what is our message or information that come from the voice just now. Okay, so this is the same concept. So we put information or signal. Okay, so this is the system. Okay, so the system will change the signal to electronic or transmit here to channel into electromagnetic waves. Okay, and then it comes here to change back from the electronics to voice. Okay, in between the system, okay, so it's not always perfect, so it will have noise at the transmitter. In the channel also it will get some noise, and the receiver also it can mix up with some noise. Okay, so this is part of the system. Okay, so if we can relate in our life, okay, so we may plan something here in our life, but if something came to the plan or to what our journey has embarked, so it is our Allah has given us akal, right, to get back to the original plan. Okay, so how we want to remove this noisy information. Okay, so we have to bear in mind that what we should do, okay, if anything happen to our life, but of course with the blessing and permission from Allah Subhanahu Wa Taala. So we just try our best. Okay. Alright, so this is also an example of a system. It is called electric circuit. Okay, so all of you are familiar with this RC circuit. So when an RC circuit, we plug in some voltage here. Okay, so the output will be certainly different from the input. Okay, so this is input and output. So the RC low pass filter. So in this simple low pass, so it can also create a filter. Okay, so the input is a voltage, the output also voltage with different type of signal. Okay, so this is called single input, single output. Okay, one input and one output. Okay, so to classify a system, there are 1, 2, 3, 4, 5, 6, 7 parameter. Okay, so is that system linear or nonlinear? Is that system time invariant or time varying? Okay, is the system memoryless or with memory? Okay, whether the system is casual or not. And then is that a continuous time system or a discrete time system? Okay, and this is also easy to identify whether the system is analog or digital. And just now I also mentioned this one, invertible or non-invertible, means whether we can change it back to the original signal. And the last one is whether the system is stable or unstable, right? Okay, so for the first characteristic, it's called linearity. Okay, so linear and linear, right? So linearity. So we want to test if the system is linearity or not. Okay, so there are two steps that we have to do. Okay, so what linearity is usually whether the input and output is linear, okay, as well as if we put some constancy of the system, is it the same changes in the input and output, okay? So if the same changes happen, so we call it a linear system, okay? The time invariance, if we delay the input, so we will have the same delay in the output, okay? And then for causality, okay, so it relates to the real-time situation. Okay, so for the time is larger than 0 is a causal. Okay, so and then stability, if we want to see how a stable system behaves. Okay, and then we have static and dynamic. Okay, for the static, if you can recall the name, so it cannot move around, okay, but a dynamic system can have the capability of storing energy or remembering its state, while a static does not. So static only happen at the current time, not the previous time. Okay, previous time represent a back, or we can remember. So that's why it can store memory or store energy, right? Example, a battery connected to resistor is a static system, okay? But if the battery, which is the voltage, connected to resistors, capacitors and inductors, we call it a dynamic system, okay? Because capacitor can store energy, okay? The main difference is the capability of capacitor and inductor to store energy, remember the state of the device. Because if we recall, if there is a capacitor, we have to consider the initial conditions of the capacitor. I mean, it can be stored, okay? So it is a dynamic, okay? And for the continuous time or discrete time, so this is just like a signal, okay, signal classification. Okay, if they are continuous time, it is a continuous. But if it's discrete, okay, like at only some certain values of time they exist, so it's a discrete. But if it's a continuous, okay, so it's continuous time, okay. And sometimes we have a system that are continuous, and at the same time it is also discrete, okay. Alright, so the first classification, if you look at the slide just now, is linear, okay, linear and non-linear. So there are two conditions or two properties, which is the superposition properties and also the homogeneity properties. Okay, so if you look at the superposition, for example, we have two input, okay, x1 and x2, okay. So now if we add up the x1 and x2, the function, is it equivalent to y1 plus y2, okay, if we add it separately, okay. And then the second properties, okay, homogeneity means homogeneity also, if we want to find another easy word, is scaling, okay. So if we scale the input with A, if the output also can be scaled with A, so it's a homogeneity. Okay, so A can be any values, constant, factor. Okay, now we want to show that the system described by the following is linear. Okay, so remember we have to do the superposition and also homogeneity or scaling. Okay. Okay, so this is the homogeneity test and this part is the scaling part. Okay. At the end, we want to prove that if we add the input 1 and input 2, is it equivalent if we do the separate y1 and y2. y1 is the x1 and y2 is the x2. Okay, so substitute dy1 plus dt plus 3y1 plus t equivalent to x1. Okay, so mean if we use the first signal x1, the output is this function. Okay, for the x2, okay, so the y2 plus 3y2t. Okay, alright, now we want to multiply it with k1, the constant. So this one, in this example, they do the same time the homogeneity and also the superposition test. Okay, so now we want to multiply y1 with k1 and y2 with k2. Okay, okay, so this is the dt part. Okay, from the first signal x1 and this one from the second signal x2 plus 3 from here. Okay, so y1 and y2, but we want to also include the scaling k1 and k2. Okay, alright, so if we rearrange this one, okay, so we will have k1 x1t plus k2 x2t. Okay, so how do I identify this? From this one. Okay, so d dt k1 y1t plus 3 k1 y1t is equivalent to k1 x1t. Also this part k2 and k2 y2. So this one is the y2t. This is y1t. Okay. So if we compare, the xt is equivalent to k1 x1t plus k2 x2t. If we add x1t and x2t. Okay, for yt, so y1t plus y2t. Okay, alright, so this is linear. Okay, for the time invariant, okay, time invariant, so we want to test if we delay the input, is it the same if we delay the output. Okay, okay, look at this function. So this is input, okay, so this is input. Okay, so we want to shift by minus t. Okay, so at the output, it is also shift by minus t. Okay, shift is there, and t, the values. So the shifted here and the shifted here is the same. So this is time invariant. Okay. Right, so the same one here. Okay, so let's see this equation. Yt is equivalent to xt. Okay, so whatever the input equivalent to the output. Okay, so this is straightforward. So if we shift minus t naught at the input, so the output also become minus t naught. Okay, so if the output and input is the same, if we change both with minus t naught, okay, so it is a time invariant. Okay, this one also straightforward because we only have x. Okay, this is constant, and then we shift this one. Okay, so it is a time invariant. And then for integration, we just minus tau. Okay, so the minus tau, so here we put minus tau as well, so it is invariant. Okay, so the next classification is instantaneous and dynamic. Okay, instantaneous we also call as static and dynamic. Okay, so if we see the definitions of dynamic, okay, so it's actually where the output depends on the past input. So it looks like we can remember what is the input. Okay, so that is called dynamic. Okay, dynamic means there is a memory. We know the past input. But if the system input or history is irrelevant, okay, so irrelevant means it only consider that particular moment or instantaneous. Okay, so that one we cannot remember, so it's a memoryless. Okay, so we also call it static. Static system, dynamic and static. Okay, so if the system has no memory, only depend on present, okay, so it's a static. Okay, if it has memory, it know it past, okay, not only past but also future, they can excite. Okay, so it is called dynamic, right? Okay, look at this example. Yt equivalent to xt, t, and then t minus 1. Mean it is need the information from the past 1 second. Okay, and then this is also we need the information from the past 2 seconds. Okay, so we have to go back. Alright, so this kind of equation or function or system is a memory. Okay, it has it can recall or excite the past value. But for this one, nothing related to the previous or the future, so it is a memoryless or static. Okay, so this is current, and then there is a capacitor. Okay, we know that if it's a capacitor, it can store energy. Okay, so the values of Vt, the output here, depends not just on current, okay, but it also have to consider the previous input or previous current that's stored in the capacitor. Okay, so that system exhibits a memory system. Okay, unlike a memoryless, okay, so if we put a resistor here, resistor is straightforward. So V equal to IR, okay, and if we have these two R, okay, in series, we have to find the sum of the R. Okay, so you can find the V out by using the voltage divider compared to the values of R2 and also R2 plus R1. Okay, so number one, if it's only a resistor, okay, so obviously it's straightforward, memoryless. Okay, so it cannot remember the past, only the present. Okay, but inductor, capacitor is a memory system. Okay, so we have to consider the past values. Okay, the next classification is causal or non-causal. Okay, if the input xt equals 0 and there are no initial condition, the input is yt equal to 0. Okay, so the output does not depend on future. Okay, so we have to identify the shifted value. Okay, so if it's minus tau, okay, so it is considering the past value. Okay, if it's plus tau, we have to consider the future value. Okay, so for causal system, previously we have identified a signal. If it's t larger than 0, it is exit at t larger than 0 is a causal. Okay. Okay, for the present output depends only on the past and presents, not on future inputs. Okay, so it's a causal system. Okay.